This is part 3 of the discussion on mole concept. We shall correlate number of moles of different elements or different compounds with a concept that same number of moles of different elements and compounds have same number of atoms and same number of molecules. Let me mention same number of moles of all elements or substances have same number of atoms or molecules. Same number of atoms or molecules. We rejected the concept last time that same number of grams of all elements and substances cannot have same number of atoms or molecules with examples. Now, this is the next stage. Same number of moles of all elements and substances will definitely have same number of atoms or molecules. We discuss it with an example. Question is, how many grams of magnesium has same number of atoms as are present in 1 gram of calcium. For magnesium and calcium who have same number of atoms, their moles or gram atoms must be same, and to find out moles, weight or atomic weight in case of magnesium as well as in case of calcium, we know same number of moles of magnesium and calcium have same number of atoms. We shall write the mathematical relations first. Everything systematically, no step is to be assumed. We should inculcate the habit of writing fully everything, not leaving anything to guess, not skipping a step, not trying to be direct, because it is the system which will give us the sound knowledge with deep roots. Weight of magnesium over atomic weight of magnesium must be equal to weight of calcium over atomic weight of calcium. How many grams of magnesium? So this we don't know. We represent it with W. Its atomic weight 24. Weight of calcium 1 over atomic weight 40. Therefore, W is equal to 24 over 40 is equal to 0.6 gram. So the answer is 0.6 gram of magnesium will have same number of atoms as are present in 1 gram of calcium. This is the simple answer to this problem. We shall have another example. That example will cover molecules. Method is same, but just practice makes us perfect. Question is, what weight of carbon dioxide has same number of molecules as are present in H are present in 1.6 grams of sulfur dioxide. Instead of elements, we have two compounds. Same formula, same technique, same method. Weight of carbon dioxide over its molecular weight. Weight of sulfur dioxide over its molecular weight. Weight of carbon dioxide we have to determine W over molecular weight 12 and 32 44. Weight of sulfur dioxide 1.6, 32 and 32 64. Therefore W is equal to 44 into 1.6 over 64 and it is 1.1 gram. So same problem in case of elements and then in case of compounds. It was a case of magnesium and calcium and now it is a case of carbon dioxide and sulfur dioxide. We will extend this concept of this concept of moles to molecules and the number of atoms present in a molecule. There are two types of molecules. Molecules which have more than one atom of the same element. Molecules which have atoms of more than one element. So the concept to atoms present in a molecule. We shall start with a molecule in which same element has more than one atom. Simplest example is hydrogen, it is H2. We shall write its molecular weight, it is 2 AMU. 1 mole of H2, this is to be converted into grams, 2 grams. H2 is formula for hydrogen molecule. So we shall write 6.02 10 raised to the power 23 H2 molecules. And what is new in it? One hydrogen molecule has 2 atoms of it. 1 mole, or Avogadro's number of hydrogen molecules will have how many atoms? 2 multiplied by Avogadro's number. 2 into 6.02 into 10 raised to the power 23 hydrogen atoms. This is another step in this mole concept. We have P4, a phosphorus molecule. Its molecular weight is, atomic weight of phosphorus 31 into 4, 124 AMU. We shall write 1 mole of P4, 124, not AMU, grams. Avogadro's number of molecules, and of course, one P4 molecule has 4 phosphorus atoms. 1 mole will have 4 into Avogadro's number of atoms. It is 4 into 6.02 into 10 raised to the power 23 phosphorus atoms. So moving ahead with different examples, we have another example. We are extending the concept called mole concept. We have S8. Sulfur exists in the form of S8 molecules. 8 sulfur atoms form one molecule. We shall study it in 12th class, the shape of S8 molecule, the shape of P4 molecule, and so on. S8, its molecular weight, 32 into 8, 256 AMU. So, 1 mole of S8, 256 grams, 6.02 10 raised to the power 23 molecules, and of course 8 into 6.02 10 raised to the power 23 sulfur atoms. Sulfur atoms. Another type of example, say it is sodium sulfate, Na2SO4, this is sodium sulfate. Its molecular weight, sodium 23 into 2 plus 32 plus 16 into 4, 46, 32, 64, and it is 142 AMU. How we lay out? One mole of sodium sulfate is same as 142 grams, same as 6.02 10 raised to the power 23 molecules. We shall now extend it in case of sodium, sulfur, and oxygen. One sodium sulfate molecule, also called Glauber's salt, has 2 sodium atoms. So we shall write 2 into Avogadro's number 6.02 10 raised to the power 23 sodium atoms. One molecule has 1 sulfur atom. This number of molecules will have same number of sulfur atoms. 6.02 10 raised to the power 23 sulfur atoms. One molecule has 4 oxygen atoms. One mole will have 4 into Avogadro's number 6.02 10 raised to the power 23 oxygen atoms. And let us extend another step. How many total atoms are present in the molecule? 2 for sodium, 1 for sulfur, 4 for oxygen, 7. This will have 7 into 6.02 into 10 raised to the power 23 total atoms. We can extend our concept to such element. We have another example. Examples help us understand a topic, grasp a topic more sincerely. We have C6H12 and O6. Its molecular weight. You know, we cannot name it by looking at it. It may be glucose, it may be fructose, it may be mannose, it may be galactose, it may be formose, and so on. Molecular weight 12 into 6 plus 1 into 12 plus 6 into 16 or 16 into 6, 72, 12, 96, and it is 142 and 80 atomic mass units. We shall write, rather elaborate, 1 mole of C6H12O6, 180 grams, 6.02 10 raised to the power 23 molecules, and then one molecule of this compound has 6 carbon atoms. 1 mole will have 6 into this figure molecules. 6, 6.02, 10 raised to the power 23 carbon atoms. It will also have 12 into Avogadro's number of hydrogen atoms. 12, 6.02, 10 raised to the power 23 hydrogen atoms will have 6 into 6.02, 10 raised to the power 23 oxygen atoms, and total 24, 6 plus 12 plus 6, 24 into Avogadro's number of total atoms. We shall supplement with an numerical problem. A glass of fruit juice has 5 grams of fructose. How many hydrogen atoms does it have? How many hydrogen atoms does it have? I have selected a problem related to this formula to save some time or add more information in the same time. Fructose, same formula. Fructose is C6H12 and O6. Molecular weight is equal to 180 atomic mass units. 1 mole of fructose has weight equal to 180 grams. This number of molecules, but we are to find out the number of hydrogen atoms. So this is the number of hydrogen atoms. Each mole has this number of hydrogen atoms, but we are given 5 grams of fructose. We shall convert it into moles, so that starting from this we are able to reach here. Weight of fructose is equal to 5 grams. Is the molecular weight 180 AMU, ਤੇ ਫਿਰ number of moles, weight over molecular weight, 5 over 180 whatsoever. Simple unitary method, 4th, 5th class. 1 mole of fructose has this number of hydrogen atoms, and this amount will have how many hydrogen atoms? Question is solved. The question is solved, and let me write the relation. Let me write the relation. 1 mole of fructose, 12, 6.02, 10 raised to the power 23 hydrogen atoms, 5 over 180 moles, 12, 6.02, 5 over 180 into 10 raised to the power 23 hydrogen atoms. This is nearly to into 10 raised to the power 23 hydrogen atoms approximately. We can use this technique in multiple choice questions. So this was the application of mole concept in calculating number of moles of different atoms present in a molecule. We shall continue in the lecture number 4 and extend this concept to more examples, and that may finish this topic. We shall start then the next topic. Goodbye.